Okay, so hi everyone, and welcome to this new HPE Developer Community Meetup. This is the July edition. And while people are joining in, I'm Frédéric Passon, and I'm very happy to see you here. Today we are welcoming Lucas Voron from HPE Networking team, and he's part of the automation PLM team, the product lifecycle management team. Before I hand it over to Lucas, I'd like to go through some housekeeping items. So, as you know, this is part of a program series, the Meetup. We have a dedicated webpage for this program where we can actually list all the existing, upcoming, and past events. So we've worked a bit on the planning these days. So I can tell you that in August there will be an HPE Morphers and Terraform meetup focusing on key features and innovation. There will be demos. In September, there is also another meetup plan from provisioning and to observability with HPE Cloud Ops software, advanced version. And I also have a date and a subject for October. So it will be Open BMC and HPE ProLiant. It will be delivered by one of our French colleagues. So you can have access to the URL and you will see the table. The registration link will be updated shortly. Just by the end of the week, the very first registration for Terraform should show up, I believe. And the next one will follow on later on in the month and in September. As part of our webinar series, we also offer the Munch and Learn, okay? And these are, I mean, when the meetups are more down to the bone type of technical type of approach, type of webinar, the Munch and Learn are more high level, industry agnostic, more of a industry trends type of webinars, okay? So leadership, vendor, product agnostic. And there is one session that is planned for September. It will actually be in a follow-up of a session that took place back in March, I believe, which was related to open source and HPE. So there will be a second panel discussion that will be led by Ria Shonet, and she has invited other people within HPE to actually discuss the open source thematic. There was a third possible webinar that we used to do, but that has been on hold for some time now. But we're working on bringing it back, which is called Keeping It Real with AI Jam series. So we will have some discussion in September with the right person to actually try to resurrect this panel discussion around AI. So stay tuned for more info on this. Obviously, you're part of the community, so we're expecting you to, skill up in any manner that you want, either by attending our webinars or by, looking at the workshops on demand program that we also provide. So think about it as on demand, free of charge, Jupyter notebook-based type of experience. You have a catalog of workshops that you can browse, and you can actually, select the workshop, click on register, enter your email, your name, and then a few minutes later, you get access to the Jupyter notebooks, and it allows you to run through a series of exercises and labs on a given subject. It could be open source, it could be HP products, it could be API automation. So we've been doing some cleanups, but we try to work again on this subject, and we should come back with some new content, hopefully in some weeks, months, I would say. Again, the developer community is a community, so we need you to amplify and to contribute and to participate. So we're very happy to see you here, but we'll be even happier when we see that you can invite some others to join our webinars. If you can also join and invite others to come and subscribe for our monthly newsletter. The newsletter is fairly simple. It's just a summary of all the activities that took place within the past months and the things that are upcoming into the community. So it could be the forthcoming events, it could be the blogs that were published lately, it could be new workshops that have been introduced. So, we won't be flooding you with emails, but once in a month we'll give you the best, of what we produced over the past months. We also have a Slack channel, okay? So it has probably more than 50 workspaces, one workspace and 55 channels, sorry. You can sign up and you'll have the chance to get in touch with, developers and other members of the community where you can exchange, you can get help on some problems and so on and so forth. So take a look at the link and sign up for joining in. You can follow us on Twitter if you want, on X. And whether you are an SME on any given subject, like Lucas today, we'll be very happy to see you working with us on the blog. So we have a dedicated open source CMS system that is fairly easy to use and that will allow you to actually contribute in a very easy manner. I mean, you need a GitHub account, you connect to the system, and you do some forking and post your and pull requests from your blog, and then we just do some reviews. And well, it's fairly, I mean, go on the page and check for yourself. You will see. You can reach out to us to deliver a meetup or participate to some events as well. I mean, just like Lucas is doing today. And you can also, create the workshops on demand should you be willing to do so. So that's really what I had to say. And this is a summary of all the different links that would allow you to join us or to contact us, so either through Slack, through the newsletter, through a mail or X, or if you want to have some information about the workshops on demand. With that being said, I think I took enough time and I can leave the floor to Lucas now and wish you a very good session. I'll be seeing you at the very end for the end of the session, Paul. One last remark is that Lucas is willing to answer all of your questions, obviously, but we'll try to keep them by the end for the end of the session. So, I mean, there's a Q&A section within Zoom, so you can post your question there. Lucas will be looking at them at the end of his, presentation and demo. We'll keep 10 minutes at the end of the session for this, so he'll be going through all the questions and we'll try to answer the best of them. Okay, with that being said, all yours, and I'll be stopping the sharing and you can take over, Lucas, right now. Here you go.
Perfect. Thanks, Frederic. Hi, everyone. Um, as Frederic mentioned, my name is Lucas. I work on the HPE Networking Automation team as originally was a technical marketing engineer, and now we've moved into product lifecycle management for automation tooling and guidance for all our customers. So today we're going to be going over how to build network visualizers and network analytics dashboards. We have a lot of different customers come to us with questions about their own tooling, about how to utilize API for their automation, uh, their custom automation dashboards. And so we wanted to do this session today in hopes of getting ahead of some of those questions and also giving you access to some of the resources that we have available for your own development. So, overall agenda today, we're just going to be going over the regular importance of utilizing API for custom built dashboards or visualizers, why you might want to do so. Then we'll go into my overall just build process breakdown. Where do I even begin? How do I get from point A to point B when it comes to displaying data on a data-driven dashboard? Then we'll do some talk on how you can be doing API discovery and testing. Um, this is going to include some shout outs along the way of some tools and resources that we offer. Then we'll be talking about what it means to define network health for you as a customer. You know your network better than anybody else. So it really is up to the customers to learn how to define network health and what sorts of metrics you're going to be putting onto your dashboards. Then we'll talk a little on doing some live API monitoring calls, languages that you'll want to be using, like I said, other tools that are available for your testing and validation. Then I'll be talking on some storage considerations, just a general overview of some time series databases that you can use for these networking dashboards. Then I'll talk on a little bit the visual side, some graphical recommendations when it comes to what charts you should be using to display what information, how to best, suit your audience and work within your customer constraints to be building, fun, usable dashboards that people actually want to use and are effective. Then I'll talk a little bit on some challenges that you may face when building out a dashboard. This includes things like scale and rate limits, and how do we deal with those in a programmatic fashion. Then lastly, I'll be going over some regular topology considerations, how you want to have your network best displayed and set up for your own use cases. And then I'll be doing a little bit of demo and closing out with some extra resources. And then we'll go into that Q&A section where I'll be taking all the questions in the chat since it's just me presenting today. Great. So the importance of APIs and visualizers. Like I said, we have a lot of customers with a lot of different customer use cases come to us asking for different things via API that they want to display, whether it's within their own internal tooling. We have our larger customers that have a lot of custom built tools by their own engineering teams. And then we have also very small cost conscious customers who want to eke out a little bit more out of Central's capabilities and are just curious about what they can do with API. But the overall messaging is that we want to make sure that as customers, you can read your network accurately. You can take a look at analytics, read out health signals that reflect your own environment in the way that is best for you. Then, one thing that I also like to lead with is there's one question that we want to be answering with a network visualizer. And the more specific you can get, the more effective your solution is going to be when you create it. So if you have a alerting or troubleshooting use case, you want to cater the design of your dashboard to that specific use case. And that will kind of help drive your development process and where you want to begin. Then the last piece is, good dashboards overall reduce uh, network outages and help you evaluate your network performance. At the end of the day, we're just working on finding human readable and accessible ways of uh, reading out errors, diagnosing issues, discovering different patterns across your network so that you can make your network more efficient and more stable over time. So let's talk a little bit on my build process breakdown that I usually consider when working with different customers. First up is gathering requirements. This can just look like what API metrics or what network metrics are important to you as a customer to determine network health. That almost always includes the up-down status of devices. It's going to probably include some hardware information coming out of your different sets of devices. If you have a switch heavy network, that can also impact the level of information you want to be showing. If you also have a greater interest in floor plan and multiple sites and layouts, that can also impact the way that you want to be displaying data. Then we want to, as I mentioned earlier, define our overall network health key performance indicators. So, um, as I said, this can be up-down status of devices. This can be hardware details like CPU utilization, memory utilization, power consumption, all these things that can indicate health across your network. Also, stuff like AP radio channel utilization over time, for example. What sorts of things or what sorts of trends and details are you going to be working with to gain real insight to your network health? Then we want to map those key performance indicators directly to API endpoints and information that we can actually get out of Central. Then we'll want to run a couple test API calls on those API endpoints just to validate and make sure that you're able to extract the correct information, the correct parameters from your devices on the network. Then we want to build some sort of repeated telemetry collector script. So this can be done in whatever language you like. I've created collection scripts in anything from Java to Python is a very popular use case language for this. Then you'll want to do some sort of sanitization or normalization on the data that you're pulling out of Central with whichever language script you use. Then you'll be wanting to tag all of that data for your own use case. So this can be adding specific things that you would filter out your network details by, whether that be groups, whether that be adding important information in the notes section of each one of the API responses, or if you're going to be doing filtering by site names, for example, and you want to have a standardized tag out of that name, this would be the time to do that. Then we want to take all that data we've collected and sanitized, and we want to put that into some sort of database. As I mentioned, I'll go over some different considerations for other time series databases. The reason we suggest a time series database for monitoring dashboards is because the best way to do monitoring of your networks is to also have that historical timeline for where you can make correlations between dips in your network health and the time of tickets or alerts that you receive on your network. So it's important to, be storing that along, be storing all of your information along with timestamps. Then from there, you have pretty much everything you need to build out dashboard visualizations using tools like Grafana or React-based tooling for custom web UIs. And I'll be showing some more of that later as well. Then you want to validate this entire dashboard and testing framework with some real use cases. Have the monitoring dashboard up and running and see if you can detect any spikes in AP radio channel utilization. Dig down into a device serial number and see if you can find some correlation between the time a spike occurs and what network traffic might look like in your own site. And lastly, of course, based off of, this entire cycle. So let's talk on a broader sense a little bit about Central's automation capabilities. Central offers three different types of API or programmatic interfaces into Central. The first of which is REST API. That's going to be the focus of today's presentation. Um, REST API supports, get, post, put, patch, and delete operations. It is probably the most basic of the three and works in a request and response format with Central. Then we also have webhooks. Webhooks allow you to create push-based style notifications that can, once an event occurs in Central, it can trigger an alert that can send something to you like a Slack message, a Teams message, an email, etc. So this is really useful for alert-based workflows. And then the last one is streaming API. So streaming API is when you have a continuous open stream of telemetry data or events that are being sent to you from Central over a set connection. Now today, we're going to be going over how you can utilize REST API for the building of your automation dashboards. However, we have a lot of customers that end up using streaming API for large volume networks as well. Um, and it also has regular lower latency than REST endpoints. However, for this introduction, utilizing REST API is probably the most user-friendly in my opinion. But as I said, we have resources for all three, and there's a lot that you can do with just REST API as well. So let's talk on Central's REST API. Central has a standardized open API spec across all of its endpoints. And the great thing about Central is it was built with an API first intention in mind. This means that everything that you can do today within the Central UI is able to also be done programmatically utilizing API. So this means there's no longer a discrepancy between, your, network monitoring platform central and whatever you want to build out yourself. And then we find that this is a really key advantage point that a lot of customers are interested in using Central for if they're very heavy in API usage. Then, as far as authentication goes, um, the authentication standard for Central is OAuth 2.0. And then all of our tokens and authentication systems are set up within GreenLake. Um, we have a unified management platform within GreenLake that can allow you to have authorization to make API calls across your central instance. Then, as far as monitoring API coverage goes, we have a bunch of APIs for all your different device types, reporting and troubleshooting use cases. And we can get plenty of great hardware details coming out of all your devices throughout the network from APIs alone. Then, as far as rate limits go, the per second rate limit for API calls to Central is 10 API calls per second, but there's no longer any per day rate limit. So you can make as many calls, I guess, 10 seconds times, you can do the math. But yeah. So now let's move into the first stage, which is API discovery and testing. Once you have an idea of some of the metrics that you want to be using, you'll want to start thinking on how can I test some of these API endpoints? And the first of which would be to begin with that open API spec. I'll show you on our HPE Networking Developer Hub where you can scroll through the list of APIs that we have available. You can take a look at example response parameters and bodies that you'll get out of our API endpoints and make informed decisions about what you can pull out of your network from APIs. Then you want to validate those parameters that you're passing into some of these calls you're making, test those calls in your preferred API client. Um, we also offer a official Postman collection for developers to utilize that they can just fork over into their own environments and then do their API testing there. And then you want to uh, be able to work within whatever environment works best for you and you're used to in terms of your own API testing. Then, after we've done some API testing, we want to think in a greater picture of, okay, I have all these API endpoints, I have all this information that I can extract. How do I define what it means for my network to be healthy or be in good standing? What this might be is for you, you need to choose primarily pain-driven health signals. So the very obvious use case for this is, okay, when a device is down, my clients cannot connect to access points. That's going to cause errors. We're going to get reports of network outages. Excuse me. How can we remediate that or be made aware of it an instant a device goes down? Um, then you want to kind of dive into some more details of, okay, how can I begin to track things like latency, loss, uptime, radio frequency quality, and overall client experience? And how can you create a vision on your network based off of those points? Then it's up to you to kind of define what it means for your clients to be in good, fair, or poor standing, or your devices themselves to be in good, fair, or poor standing. This can mean setting thresholds for different things like CPU utilization. Going past a certain level might want to trigger some sort of alert on your end or be cause for concern for a network operator to go in and figure out, okay, why is this single access point being heavily overused? Does it have too many clients associated with it? Do we need to add another access point around it to help, remediate some of the some of the strain on a single access point, for example. Then you want to be able to tag your data, as I mentioned, for filtering. This can be doing things like tagging by site, by building, by floor ID, um, by role, or any device type. Making sure you tag your data by these metrics will give you more flexibility on the UI side when you're building out your user interface for your dashboards. Then one thing to also shout out here is that Central has its own health metrics API. So we have a couple metrics that are already available for site health, where within Central we do some of our own analysis on your network hardware performance and determine site health. We have some client health endpoints as well. So see what's there, see if it aligns with your own health vision, and move forward making, whatever decision works best for you. And then another thing is, when considering that language of uh, your development choice, if Python is, sort of your go-to. I wanted to shout out we have our PyCentral v2 library. This is a Python SDK that myself and our team work on to sort of help uh, ease your interactions with Central REST APIs. The PyCentral SDK itself manages things like authentication inherently. Um, we have a ton of importable classes and methods that you can utilize throughout your development. It's just a standardized way to kind of make development slightly easier. We upkeep this PyCentral SDK um, and work on it consistently to improve it for all of our customers to interact with our APIs. So now, you might be thinking, okay, this is great. Uh, I have an idea in my head now of what network health could look like. I have an idea of some APIs. Where do I go to actually find all of this information? And let me take you there. So this is our HPE Networking Developer Hub. This is our one-stop shop that we send all of our customers to first if they have concerns about development across all of our networking products. Um, Here, I'll just take us straight into the Central Specific page where we have links to guides as well as our monitoring, reporting, and troubleshooting API. And then we also have some configuration available. I'll just be focusing on the monitoring, reporting, and troubleshooting section. So if I click into here, this goes ahead and shows all of the existing API endpoints that are readily available within Central. As I mentioned, we have endpoints for overall devices, things like site health, and these were those parameters I was talking about when it comes to your own testing and validation. And with each one of these endpoints, we can also take a look at some example responses, and this is where you can uh, check out, okay, I have these network pain points that are going to translate into overall health. Does a parameter like this exist in an API response body? This is where you can go with your initial pass and then do some testing yourself. One thing I'd like to shout out is within this platform, you can also select a developer language to kind of help give you a kickstart when it comes to testing individual endpoint URLs. You can also do test calls directly within the web UI by authorizing with your own client ID and credentials that you've generated over in the GreenLake side. Another few endpoints to shout out here are things like getting an overall list of access points. Um, this will contain plenty of rich information on, you know, your access point site name that it's associated with, perhaps a group name as well within your network configuration. And then, as I mentioned, you can get some of those hardware details that might be indicators of your access point or device health. That's all available by API here, and something you can check out. I also wanted to share with you our Postman. This is our official Postman workspace where we host this central Postman collection. As I said, you can fork this collection directly down into your own workspace. This is where you can do some of that API discovery and validation on your own end. Um, Here we have that same list of monitoring endpoints and guides, information on how to set up your environment, get your credentials in, and work all within Postman to do some of that API testing. And then from a more advanced programming perspective, if you're working with Python, this is our PyPy or PyCentral. Um, this shows different versioning that is available. Our PyCentral SDK is now up to the 23rd alpha version of its 2.0 state. So, as you can tell, we make updates to this regularly and are consistently trying to improve your developer experience with Python and utilizing this SDK. All right. So let me continue on through with our process. So let's speak on storage considerations. How will we want to answer the question of how will you store your own data attributes and what's the best way to be grouping things? First off, we want to be grouping metrics by measurement families of some sort. As I said, we'll want to be doing uh, grouping based off of sites, device type, group names, you name it, but some sort of family grouping that is going to uh, help you with how you store uh, all of your information. As I mentioned, very important to use tags for added dimensions and filtering. Later on, it's going to give you the most options in the UI afterwards. Then use plenty of fields for numeric values or state values that you want to chart and aggregate in the future. And be sure to keep timestamps fully consistent across any of your data that you're inputting into a database. As I mentioned with a time series database, that kind of removes that complexity of making sure that your timestamps are fully consistent. Um, so that's why I recommend using those for monitoring network analytics dashboards. Then the last one is think a little bit on retention before you do your collection of a first large data set. Um, some of these API endpoints can be pulling a lot of information from Central at once. I'll be showing you a dashboard that I created myself that's pinging 40 different endpoints. Okay. Um, so when you're pulling all this information and storing it, it's important to think on, okay, what is necessary to put into this database, um, and think on the overall storage capabilities of the database, and think a little bit more on your own hardware as well, what you're capable of running on your specific machines and or hardware building out these dashboards, right? Now, after we've thought a little bit about how we're going to put things into the database, then we can speak on some regular graphical recommendations, right? The basics are this. You just want to be utilizing overall time-based charts like line charts when it comes to finding analysis of trends over time. This is really big for things like correlating those hardware metrics with spikes or issues in your network. So I've built out dashboards in the past where I have line charts of AP channel radio utilization, and we've seen spikes in channel utilization at certain areas where we know that, like crowds, for example, are moving from one section of a venue to another. And so you can actually really extrapolate real life insight out of these metrics, but you want to make sure you're putting them in a readable format that is, easy to understand and easy to evaluate to from a glance, right? Over here, we have this graph of CPU utilization. You can see those spikes occurring at those specific timestamps, right? And it's really easy to take a look at a device, see what's wrong with a specific serial number, and then do that data correlation on your own regard. Then you want to be using stack charts for things like overall capacity or composition throughout. So this can look like stacked bar charts, splitting up charts based off of those grouping details that we talked about, whatever tags you end up using. Then for things like uh, doing heat maps, this is going to be primarily used for when you want to gauge concentration of clients around specific access points. Um, Also, sometimes we have customers who like to put on heat maps on top of their floor plans so that they can see sort of the movement of clients over time. Then you want to make sure that you keep and add annotations for things like incidents, firmware updates, or firmware that's out of sync, for example. Um, and we want to be able to keep track of network outages over time. So charting that up-down status over time is really useful. Then the last portion would be to align times across all of your panels for the best ability or the best visual ability to do data correlation, right? A lot of times when you'll see these CPU utilization spikes that are maintained over time, you'll probably see corresponding AP channel upticks at the exact same times. And when you see those shared metrics that are both spiking over time, that's when you can take a look at a device and say, oh, my hardware is acting up. The channel utilization is acting up. There's clearly a high concentration of clients around the specific point. Is that past a threshold that I deem to be healthy for my network? If so, how do I get that serial number, locate it on your sites, and dispatch a, tech to go in and remediate the situation by adding another access point, changing some of the RF values on the access points themselves. So yeah, great. So let's talk some of the issues that you might experience when you're building out your own programs. The two main ones that I think of come out of the following sections. The first of which is just your own network setup, primarily dealing with the scale of devices and the number of API calls that are going to be made. These two kind of go hand in hand, right? And with those number of API calls that you make, as I said, the number of calls made per second, there are there's a 10 API calls per second rate limit within Central. So we want to keep both of those in mind when you're programming and make sure that you're gracefully handling errors or rate limiting issues when you are pulling from Central, or also when you're writing into your time series storage database itself. Um, so this means um, it's useful to do things like use bounded worker pools. So keep like a set limit on the number of workers that you're going to be utilizing to pull all these API endpoints. In addition to that, with all of your data that you've grabbed, you want to batch up your writes to storage rather than pulling a single um, chunk of information and just shoving it directly into the time series database. Sometimes batching those together and writing to the database is going to lead to more efficient writes and less errors too when trying to do concurrent writing into a time series database. Because you might be able to grab the information from Central no problem, but you want to make sure that it can eventually find its right place within the time series database itself. Then, as I said, you want to develop some sort of error handling for, back off and retries on failures of API calls, on failures based off of rate limiting. So this is going to be conditionals if you get a 429 rate limit error coming back from the API endpoint, you'll want to set a time delay on the next set of calls that you're going to be making to ensure that you're not within that 10 calls per second rate limit. Then, um, as I mentioned, separate your work as best you can between different categories like sites, WLANs, devices, radios. And also, one important thing to note when it comes to making a lot of repeated calls, it's best to use Central's built-in cursor pagination. This is with every API response. Let's say you have, 10,000 devices. The APIs have a limit of 1,000 devices per call. But what we do is we give you a number where you can begin your pagination before moving on to the next call. Make sure you're using that instead of your own pagination to avoid confusion. Okay, so here's some time series database considerations. Um, First, we have InfluxDB. This has been my go-to so far. It's really great for very metric heavy data ingest and has really fast database writes. So for a dashboard that I'm going to be showing you at the end of this that has over 40 endpoints that we're calling, it's a lot of metrics. Each one of those endpoints, as you saw, has a huge response body and tons of parameters. And for me, just to see what was possible, I wanted to get as much of that information into my database as possible. So for that reason, I've chosen Influx in the past to build out dashboards. Then we have Timescale DB. Timescale DB, for those of you who are very familiar with SQL and want to be doing joins to get relational reporting and are familiar with utilizing SQL to do that and do joins on your data sets. Um, Timescale DB is a really good option with some of its built-in features. Then for more polling-based workflows or workflows that are very alerting first, Prometheus is a great option as well that you can utilize. Then if you're thinking on storage capacity and long-term historical data storage, Victoria Metrics is a good time series database that you can use for some of those higher volume requests over time. Great. So the last piece of the puzzle are some topology considerations, right? So this is once again just kind of keeping your user in mind when developing the UI of your dashboards, right? We want to try to build out our dashboards in an easily understandable UI for your network operators. As I said, you want to be separating by sites, and you want to try to build out something that is most efficient for users, right? Um, and your specific use case too. As I said, some customers, have a lot of different sites, a lot of different office buildings. They have a lot of separate floor plans. They want to be able to visualize and easily take a look into all of that information and see where access points are placed throughout the network. And our APIs allow you to do all that. But make sure you're just designing your UI with that user in mind and working within what your own network topology looks like. Um, as far as, let's see, yeah, as far as general advice and information when it comes to displaying all this stuff, you can get a lot out of each of the individual API endpoints. The amount of granularity that you have into your network can also change based off of your own audience. If you're looking for a higher level network dashboard, perhaps you don't need to be storing as much information and also displaying a high level of specificity in each one of the metrics that you show. Now, if you're working with if the dashboard is for, on-site monitoring operations and you want to have things be as granular as possible, build out your dashboard with that in mind and think of okay, I want to be filtering based off of my individual device serial number so I can really narrow down issues for on-site network engineers. Um, create whatever UI with all of that in mind is the only message I'm trying to hit home here. Okay, so that is a walkthrough of the overall process. Now I want to take you through an example tech stack that I have built out based off of this these considerations that I've made myself for our general, large campus dashboards. So uh, overall, we begin with the site and device level details. Then we're making our API calls to Central. I utilize our PyCentral v2 SDK and a Python script to do the consistent polling of data. And then I put all of that data into an InfluxDB time series database and then shove that out into two different dashboards. One is a Grafana dashboard, very popular tool that's open source and free to use. And the second is a Next.js dashboard that I custom built utilizing, React. Oh, and another thing to note is this set of dashboards that I created is all within a set of Dockerized containers. Um, The reason being is I wanted to make this entire central dashboard demo that I'm going to show you as portable as possible and easily shareable amongst our different customers trying to get started with network analytics dashboard, building. So without further ado, let's go into the overall dashboard demo. So first, one great thing about running this dashboard is it's only a single command that you have to run since everything is within a Dockerized set of microservices that are all running simultaneously. So I'll run this Docker compose up build command, allow some of these packages to be ran, and then let me walk through some of those different services that are being triggered by this Docker compose file. So the first of which is our InfluxDB database and this fetch.py file. This fetch.py file is what's making the individual API calls and utilizing our PyCentral SDK. Each one of these calls or each one of these functions is making a series of calls, um, building out individual tags and adding those into the InfluxDB database. So let me show a good one here. Okay, so this is the site health API endpoint that I showed earlier. This site health endpoint here, this is kind of the level of tagging that I was speaking on as to what's getting written into the database. So in this case, I'm writing in things like site ID, site name. I'm also extracting health values for, different groups, whether they be poor, fair, good. I'm pulling out a ton of different information, and this is what's being set into the InfluxDB. As I mentioned, all these tags and fields that we've added into the database are going to be really useful when it comes to filtering out and displaying things in our UI. So that just kind of gives you a taste on a per endpoint basis as to how that works. And then what I also want to show on this side is our two UI outputs. Um, Here within this Grafana level, we have a series of JSON files. These are pre-built dashboards in a JSON format that get uploaded into Grafana within its locally hosted service. And so these are getting pulled from this project directly and uploaded into Grafana. Then we also have our next dashboard. For those of you familiar with React, you'll see our full set of pages and index pages, all of these elements built out for the dashboard here. And now that we've given our dashboard some time to run and make some polls to data, you can see all of these writes that are occurring to the Influx DB database. Let's see what is populated on our UI. So go ahead and reload each one of these pages here. So first, I'll take you into the InfluxDB um, database where we have this venue data folder that's being generated and then filled out. Within this venue data, we have a whole host of metrics that we've pulled from different API endpoints, from clients to gateway metric, etc. Here's where you can play around with the details of your individual API writes and calls. Then on the Grafana side, here's where things kind of get, more fun and interesting from a visual perspective. Here we have a homepage of a bunch of metrics that we've pulled, a list of total devices, a breakdown based off of device type. Then we have, as I mentioned, overall site health endpoints. We have client health on a per site basis as well. And as I mentioned, the ability to do this sort of correlation and filtering is all based off of those tags that we wrote into the database, right? Then we have a full list of all of our devices, site locations, and a mapping system as well. And then I'm just going to take you through the access point specific page here where we have up down status. And then for our critical access points that are down, we have more specific information that's available and generated. Then we have overall CPU utilization and the ability to take a look at each one of these, correlate spikes with a specific device. So yeah, this access points utilization is at 100% at this moment in time, right? That might be an issue that we should look into, especially based off of the performance of the other access points we have, right? And these are kind of scrunched up because there's a lot of devices in the network, but within Grafana, you can adjust the height shown for all of these individual metrics. We have memory utilization, power consumption, device on or offline status over time. Then I also want to show this network page. This network page has a lot of great info, like total transmitted and received bytes, information on connected clients and their client experience as well. Um, we have some WLAN information where we're getting some average parameters like MOS or latency and packet loss jitter, right? And then as we continue to scroll, we can also see device locations on a map too. Each one of these device locations can also show you a number of connected clients that are available. Then we have a full list of Wi-Fi client locations. It looks like data for AP radios isn't in the database just yet. Sometimes it takes a little longer to write, but this will show a full series of graphs and a table of information um, in that respect. Now, on the Next.js side, sorry if I'm also speaking fast. We're coming up on time here, so I want to make sure we're able to get through and see all this good stuff. Um, this is our overall sites, and on a per site basis, we can do filtering for on and offline devices. These are, some of the floor plans from this specific thing. We can take a look at, individual access points and actually see uh, connected clients um, and see whether or not they're connected. We can do floor plans based off of different different levels within an office building, for example. We can also do high level aggregate stats, all of the information that I also showed on the uh, on the um, on the Grafana side is all available here as well because they're sharing the same database. Then here I also wanted to show, the ability to filter based off of individual device serial numbers is pretty important when you have a very large, like this is unintelligible. You can't really read this, but if you have a serial number in mind that's showing off really high utilization spikes, right? I can analyze this over time and do some correlation. And each one of these is lined up to the same set, right? So we can probably see high memory and CPU utilization occurring at the same time for the same access point. Um, yeah, so that's just a taste of all of that information that is possible to garner using REST API. Um, this project is open source and available on the Developer Hub, as I showed. And without further ado, I want to show these additional resources and get into some of that Q&A.
Yeah, there are a few, and we have only 5 minutes left. So the first one was really from Ron Dharma, and he was asking about, what about push, use of webhooks instead of REST API. So how would you build up the same architecture only using webhooks? I think is the
Yes.
question.
So webhooks aren't going to be for, consistent telemetry monitoring. Webhooks are going to be for alert-based monitoring. So this is when you have something in your network that is going to trigger an alert. That alert is going to call a webhook URL that can do things like send you an email or send you a Slack notification, etc. So you can set up webhooks within the central UI that's available and get those notifications.
Okay. The second question was from Mark, and he was asking whether the link available for the project. So you said that it's available on your developer hub. So maybe we'll share the link in the Q&A, or I don't know or maybe you can bring up the URL itself so people can actually see it, but or email you. I don't know. What's the best
Yeah.
approach?
Yeah, as I said, it's available on our developer hub. I can take you right there on our guides page here. If you scroll pretty far down, we have a lot of content available. There's this central large public venue monitoring dashboard. This
Okay.
is the online guide. It has a link to the repo as well. As I mentioned, this is all open source, readily available for you to try. I have some recommendations here within requirements of your lab environment that you need to get things also up and running.
Okay. And the last question from Ron was, what about the resolution of the dashboard, and can it be real time? So
Right.
what is the delay between, ingestion and display?
Very fair. When you're utilizing REST API, it's not going to be, instantly live. If you want to be seeing full on live trends, streaming API is probably going to be your best bet when building out your own dashboard use case.
So I'll be taking just the last minute to thank you all for participating to this meetup, and thank you, Lucas, for delivering it in a very good manner. And we'll be seeing you in a month or in the end of August for, as remember, a Morpheus and Terraform related session. Oh, there's a new question that popped out. So do we have any option of streaming data using gRPC?
Um, I I don't know. I will have to get back to you on that.
Okay, so Ashcock, we'll have to come back to you, and so maybe you can send out an email to Lucas, and
Yeah.
he will try to answer you offline for this one.
Yeah,
And
that would be
with
great
that,
to email
yeah.
that PDL, networking dash automation.
Okay, so email on the network automation at hp.com, so you get an answer. And you can also reach out on Slack, I suppose, as well. So
Yes.
that's another possibility. So with that being said, yeah, as I said, next meetup on August for Terraform and HP Morpheus. Another one in September regarding Cloud Ops. And in October, it will be around OpenBMC on HP ProLiant. So we're pretty packed for the coming months, and we'll try to get back to a monthly series when we were bi-monthly this year because of lacking of resources, but we're trying to address that now. So that's being said, we're top of the hour. I'm thanking everyone for joining in and wishing you a very good end of your day. We'll be seeing you next time in August. Have a good day. Bye-bye.
Thanks, everyone.